All right, everybody, welcome to Earth Science. If you were absent today, didn't get a chance to look at these, so let's check them out quick. The surface temperature of which sample increased at the slowest rate? Water, copper, basalt, and iron. That's a straight up reference table question, but I think a lot of us are starting to memorize this one. Water being very high on this chart. The specific heat chart heats and cools very slowly. That's how much energy it takes to get a gram of it to go up by a degree C. It's more than these other ones. So if you put equal energy into all of those bins, whatever they are, the one that heats the slowest is going to be the water because it has the high specific heat. I don't know my pen tool, but water. Which graph best represents the relative wavelengths of these different forms of energy? So this isn't something I've ever said to memorize. And when that happens in your head, you got to say, that's probably a reference table question. That's the hardest part of this, is realizing that it's a reference table question. Once you realize that, it's actually very easy. On this side of this table on page 14 are the decreased or shorter wavelengths. Over here are the longer. So just do the four that they chose on that graph, which was UV, infrared, microwave, and radio. And there's your answer. They get longer and longer and longer and longer. Sorry, it was X-rays, but either way, as they get longer and longer and longer and longer, that's what we're looking for. Choice 2. We'll look sideways over here. Most of the energy radiated by land into space. What does everything that's warm in this universe give off? You guys used the camera, the infrared camera. It's over there. Infrared. Things give off that heat energy that's infrared, and that's what gets trapped by greenhouse gases. That is going to come up at some point. An increase in the amount of which gas is thought to cause global warming. So what are the greenhouse gases? We're going to want to know all three. Let's figure out how I can write with this. That's certainly not it. But carbon dioxide. Let me turn this craziness off, sorry. Carbon dioxide, methane, and water vapor are the three greenhouse gases. I would come in with those three in your head. Be ready for that. When Earth cools, most of that energy transferred from Earth to space, which would be infrared, how does that get out? It radiates out from the planet. You right now, you're radiating heat out to your room, the room you're in. The planet radiates its heat back out to the atmosphere. State the amount of energy gained by each gram of water that evaporates. That's a straight up reference table. Again, when it's ultra specific like that, that's got to be the trick in your head. Go to the tables. And evaporation is vaporization. So we're looking for this one right here. Vaporization. It gains 2260. That was your answer, 2260. Joules is the unit there. Which graph best shows the relationship between the concentration of CO2 in the atmosphere and the amount of radiation absorbed? This is the idea with climate change that we'll continue to talk about later on. Right now, really all we're saying is that greenhouse gases do absorb infrared, very easily demonstratable. So if we have more and more and more of those greenhouse gases, carbon dioxide being one of them, then the atmosphere will absorb more and more and more of the heat. As the CO2 goes up, the energy absorbed goes up. Choice 1. Expected temperature range question for sure. I mean, we did that whole lab on it. We talked about it at length. If you have a large ocean nearby, why does it moderate temperatures? That means you're not getting as hot in summer, nor are you getting as cold in winter. It's a smaller range. Why? Because water changes slowly due to its high specific heat. And again, you don't have to memorize that necessarily, because you can look right here and see that liquid water does have a high specific heat. It's higher than all these other ones. So if you live near water, where you live is not going to change temperature as much as if you live far from water. Very cold climates occur at Earth's north and south poles because the polar regions, it's this low angle idea. When the sun's energy comes in, it hits directly overhead near the equator, somewhere in between the tropics. But way out by the poles, it comes in at a lower angle, which is why it's so cold up there. It's like right now, this time of year too, right now, December 7. We're getting closer and closer and closer to the 21st, which is the day where it's lowest in the sky, so least efficient at transferring energy to us. During which phase change will the greatest amount of energy be absorbed? That word right there is key to getting this one right. The greatest amount of energy absorbed by a gram of water. And all those phase changes, again, are listed right here. So we got it's either gained or gained. Those are your two answers. And one of them is 2,260, and one of them is only 334. So that's your answer right there. Vaporization, which is evaporation. Which one did they give us here? Evaporation. Water vaporizing, going from a liquid to a solid. 4 surfaces that absorb insolation, dark and rough, are the things that heat the fastest. So if they want, that's what they want here, right? The greatest amounts, that will be D, the dark and rough one. The white and smooth will be the least. So A is the opposite. D is the correct answer. B and C would be somewhere in the middle. People did okay with this question today. The key word is convection. We got to know what convection is, which is the flow of a fluid, of either gas or liquid. Because 2 feels like it could potentially be right. 2 might be right if that question said radiation, like the heat that just radiates out from the coals that you can feel like this. But when it comes to how the atmosphere moves around your bonfire, it's number 4. 4 is the best answer. Sorry, that's sideways. I could probably change it here, but we're almost done. Slightly mean on this one, and I won't be this mean on the test. I'll make you just do exactly what it says on the chart. But if we had to change from ice to liquid, you got to deduce what that means. That's what melting is. How much energy is required? So it's this. And again, the questions I do, I won't make you go through the anguish of multiplying times 5. The answer is 334 joules for every gram. This question is ever so slightly meter because they said 5 grams. So it's that 334 off the reference tables, which will be the answer tomorrow, times the 5 grams, which ended up being 1670. And why is locations in New York are warmest in summer? Because summer is when the sun gets at its highest angle. So both of those look good to me. And then what is the other thing? Short duration or long duration? Duration is how long something takes. So how long is the sun out? You know this from your life. In summertime, the sun's out for a long, long time. It comes up early, it stays up late. So that is going to be choice 4. Most intense and longest duration. Study. Let's nail this thing tomorrow and be done with it. Thanks, everybody. Be nice to each other.